Alright, good day everyone. So welcome back to my YouTube channel. This is Kasaligan Vlog. And today we will be talking about or understanding the area under a curve. So that is Kasaligan Vlog and this is Calculus. So what is the area under the curve? The area under the curve is defined as the region bounded by function, vertical lines representing the function bounds and the x-axis. So the graph above shows that the area under the curve of a continuous function, the interval a to b, that's one. So from a to b, represent the vertical bounds of the function. This one of the function. The region has to be bounded by the x-axis all the time. Okay, so this is what the area under the curve. So how to find the area of the curve? First, when calculating the area, the curve of f of x, use the steps below as a guide. First, you are going to graph functions, curve, and sketch the bounded region. Second, set the boundaries for the region at x is equal to a and x is equal to b. Third step, set up the definite integral and separate the definite integrals found above and below the x-axis. Evaluate the definite integral and take the value if the region is found below the x-axis. Okay, so cases for all positive position of region. In case number 1, an area under the curve found above the x-axis, this is the figure. When the area below the function's curves is located entirely above the horizontal axis, first is you're going to set up the definite integral expression. Second, apply the essential properties and antiderivative or antiderivative formula to find the function's antiderivative. And next is evaluate the antiderivative or integral at x is equal to b and x is equal to a, then subtract the results. That is for results for case number 1. And for case number 2, area found below the x-axis. So this is the case number 2. So the area below the x-axis, this one, below the x-axis, when the area below the function's curve is located entirely below the x horizontal axis, apply the same steps as the case number 1, but you're going to take the absolute value of the resulting expression because the area is always positive. Okay? And case number 3, area found at both regions. So this one, both regions. So when the area is found partly below and above the horizontal axis, identify the interval where the area is found below and above the x-axis. Found the different integrals representing the area below the x-axis, enclose them with an absolute value, and apply the same steps as with case number 1, then add the results to find the total area. So let's try this example number 1. So this is for case number 1, which is above the horizontal axis. Find the area bounded by the curve f of x from x is equal to -2 to x is equal to 2. So this is case number 1. First is set up the definite integral expression. So we need to find the definite integral expression and apply essential properties and antiderivative formula to find the function's antiderivative and evaluate antiderivative or integral as x is equal to b and x is equal to a, then subtract the results. So let's have first number 1. So we have to find first what is this is the illustration. So this illustration would help us so what the curve is. So what the curve looks like. Okay, so we have here integral of 4 minus x squared dx is equal to integral of, we are going to set up first 4 dx minus integral of x squared dx. Next is we are going to have 4x then minus, this is x cubed over 3 plus c. Then we have here 4x. Okay, this one is correct. There's x cubed over 3 plus c. So this is the final answer for this one. The next step is we need to set up for the area. In finding the area, we have here subtract. So first is 4x minus x cubed over t from negative 2 to 2. So we have here, okay, so we have 4 times 2. This is a positive side. So they have 2 cubed over 3. Then we have to subtract. We have 4 times negative 2 minus negative 2 cubed over 3. So we have to subtract here from positive minus the negative, the upper and the lower. So we are going to compute here. So this is 4 times 2. That is 8 minus 2 cubed, 8 over 3. Then minus, this is negative 6 minus negative 8 over 3. Okay, so we have to simplify. 8 minus 8 over 3 is equal to 16 over 3. And this equal minus, this is 6, negative 6 plus 8 over 3. Okay, this is negative minus negative 10 over 3. Then after which we have here, okay, let's go back here. 8, this is 8 rather, 8. So 8 minus, this is negative 16 over 3. Then this will become plus. So therefore we have 32 over 3. So the area bounded by the curve from x, for f of x is equal to 4 minus x squared from negative 2 to 2 is 32 over 3. Okay, that's the area. So we need to see the area. This is 32 squared units. Okay, that is example number 1. Squared units. Because this is area, squared units. Next is we need to find the area bounded by the curve g of x is equal to x squared minus 9 from x is equal to negative 3 and also to 3. So first is we need to set up the integral or the integration. So integral of x squared minus 9 dx is equal to integral of x squared dx minus integral of 9 dx. Okay, so we have here x cubed over 3 minus 9x plus c. So we have set up already the integral, so we need to find the area. Area bounded by, so this is below the horizontal axis. We need to take the absolute of the result. So first is we have x cubed minus over 3 minus 9x from negative 3 to 3. So we have here to subtract. So this is 3 cubed over 3 minus 9 times 3. Then subtract. This is negative 3 cubed over 3 minus 9 times negative 3. So we have to simplify. So this is 3 cubed 27 over 3 minus 27 minus negative 27 over 3 plus 27. Okay, then after which we are going to simplify. So this will become 27 over 3 minus 27 is negative 18. Then minus, okay, negative 27 over 3, then plus 27, this is minus 18. So the answer of this one is negative 36. But since we need to get the area, we need to take the absolute. So therefore, the area is equal to 36 squared units. So this one. Okay, that is example number 2. Let's proceed with example number 3. Find the area bounded by the curve h of x is equal to x cubed from x is equal to negative 2 to 2. Okay, the first step that we're going to do is we need to set up, again, to set up the integral. So integral of x cubed dx is equal to, this is x raised to 4 over 4 plus c. So the area now is equal to, so it's stated in case number 3 that identify the integrals, then after that one, for the different integral representing the area below the x-axis, enclose them with absolute. Apply the same steps at case 1, then add the resulting values to find the total area. So we need to take the absolute. So this is x cubed over 4. Okay, from here, negative 2 to 0. Okay, from here, negative 2 to 0. Then we are going to add the area from 0 to 2. X raised to 4 over 4. Then we have here from 0 to 2. Okay, we need to add the area. So area is equal to, this is 4 raised to 4 over 4 minus negative 2 raised to 4 over 4, then plus, this is 2 raised to 4 over 4 plus 0 raised to 4 over 4. Then area is equal to, this is 0, this is negative 2 raised to 4 is equal to 16. 16 over 4, then plus 16 over 4. So next is we need to add, but you need to take the absolute of first is 1. So area is equal to 4 plus 4 because we have to take the absolute. So area is equal to 8 squared units. So we need to add the area of this one and this one. So find the area bounded by the curve h of x is equal to x cubed from negative 2 to 2. Okay, so try this at home. You're going to solve 1 to 6 and submit it during our class. Thank you so much for listening, and I hope you enjoy the moment of watching the video. And please answer this one and comment your answer and say something about the video. Or if you have corrections, please correct. Thank you so much and God bless.